Okay, 4.8. Equations of perpendicular bisectors and midsegments of triangles. So we talked about this before. Perpendicular bisector is a line, ray, or segment that is perpendicular to a side of the triangle at its midpoint. And remember, it does not have to come from a vertex. So we're going to first graph RST. So graph R at 0, 10, S at -5, 0, and T at 5, 5. And then we're going to connect our lines. Now it says write an equation for RS. Now let me put my R and my S and my T. So to write the equation for RS, well, first off, we need, well, we can find the slope, or we just count, because we know the y-intercept is 10. So we can put in y equals mx plus b form pretty easy. Okay? So my b is 10. My slope is obviously positive, so I'm going to count down and left. So obviously I'm going to count down 10 and left 5. Well, that's 2. So the equation of the line is y equals 2x plus 10. Now, write an equation for the perpendicular bisector of RS. Now, we're not doing that yet. These are the steps to find that. So first we have to find the midpoint of RS. So that's going to be 0 plus -5 over 2, and 10 plus 0 over 2. So that's going to be -2.5 comma 5. And this is why we use straight edges, because my line was obviously a little bowed out. I connected those points with a straighter line, and notice -2.55 is right there. That does make sense. Now, the perpendicular slope to +2 is going to be -1/2. So we're going to write now the equation in point-slope form using this information. Again, we write y minus, we leave it blank, equals m times x minus, we leave it blank. And we drop in our y, 5. We drop in our x, -2.5. And we drop in our slope. And if we want to clean that up, y minus 5 equals -1/2 times x plus 2.5. And that will be the equation for the perpendicular line. And if we want to, we could draw the perpendicular line by going from this point, from the midpoint, and going down 1, right 2. So down from 5 to 4, in the middle, and right 2. Sorry, these graphs kind of messed me up because the numbers are actually in between 0 and -1. So down 1, right 2 would actually be right there where that is. And then down 1, right 2, down 1, right 2. If we draw that line, that would be a perpendicular bisector. Again, you didn't have to do that, but just showing you how we would. Midsegment, refresher. So a segment with endpoints that are at the midpoints of the sides of the triangle. Every triangle has 3 midsegments. So here, here, and here are all midpoints. here, here, and there. And you know they're midpoints because those two match, these two match, and those two match. And when we connect all those midpoints, we get the 3 midsegments. So let's refresh ourselves on the theorem. The theorem says that the midsegment is parallel to another side and is half the length. So if we knew that, say, this one was 7, this would be 14. And vice versa, if we knew this was 20, we would know this is not 11, 10. It's got a 2-to-1 ratio. How can we tell BD is a midsegment of ACE? Well, B and D must be midpoints. So let's find our original spots. C, just list them, A, B, and C. Sorry, not A, B, and C. A, C, and E. So A is at -10, -6. C is at 0, 10. And E is at 10, -6. So we're going to do AC, find the midpoint of AC. A is x value is -10 plus C's x value, which is 0, and A's y value plus C's y value. So that gives us -5 over 2, comma, 4 over 2, which is -2. Sorry, this is -10. I got ahead of myself. And that's going to be -5, comma 2, which is point B, we can see right here. Now we're going to do CE. So the x value of C is 0, plus the value of E, which is 10, divided by 2. And C's y value plus E's y value divided by 2. So 0 plus 10 divided by 2 is +5. 10 minus 6 divided by 2 is 2. We go over to 5, 2, and there's point D. So we've just proven that BD is a midsegment because it connects the midpoints of AC and CE. Draw a triangle with these vertices. So 0, 0, 2, 8, and 10, 4. I'm going to use my straight edges. Be as accurate as possible. Now add points 1, 4. Let me put A, K, L, and 1, 4, which is going to be called M, and 6, 6, which we're going to call N. Now we're going to try to prove that this is a midsegment using slope and distance formula. Okay, so we know that we can just find the midpoint of K and KL, and the midpoint of KA, and if those match up, we know it's a midsegment. And that's fine and dandy. But we're also trying to prove it the other way. And that means we need to find the slope of AL and the slope of MN. And they have to have the same slope to be parallel. That's the first thing we're going to do. So AL, and so A and L, we're going to find the slope. So y minus y over x minus x is going to be 4 over 10, or 2/5. And then y minus y over x minus x. 2 over 5. They have the same slope. So we know that AL is parallel to MN. Now we have to do the distance of both. I know this is everybody's favorite. So the distance of AL is the square root of so we take the x's 10 minus 0 squared plus the y's 4 minus 0 squared. So the distance is 10 minus 0 is 10, which is 100, 116. AL is the square root of 116. Now we're going to do the distance of MN. Square root (6) minus 1. That's x minus x squared plus y 6 minus 4 squared. So that's the square root of 5 squared, which is 25, plus 2 squared, which is 4. So that's the square root of 29. Well, the square root of 116 as a decimal is 10.77. And the square root of 29 is 5.38, which is half of AL. So MN is 1/2 of AL. So we've proven that they have the same slope, and we've proven that one is half the other, or the other is double the other. So we know that it is a midsegment. Okay, so here we go again. View triangle, -2, 3. A, 4, 5. Okay, 6, -1. L. New points at 2, 1, call it M, and 5, 2, call it N. And we're trying to prove using midpoints of the triangle sides. So we need to find the midpoint of KC and AC. So AC, the midpoint is -2. Sorry, the half C is an L. Can't remember my own handwriting. AL, let's say, -2 plus 6 divided by 2. My y's are 3 plus -1 divided by 2. 6 minus 2 is 4. Divided by 2 is 2. 3 minus 2 is 2. Divided by 2 is 1. 2 comma 1. Verified. Now let's do KL, not KC. 4 plus 6 divided by 2 for the x's, and 5 plus negative 1 divided by 2 for the y's. 6 plus 4 is 10, divided by 2 is 5. 5 minus 1 is 4, divided by 2 is 2. Verified. It is a midsegment. And that's it.